Bismillahirrahmanirrahim, and this video will be solving end chapter problem number 10 and 11 from chapter number 2 of EDC's book by Mr. Boylestad, and this is on the request of a student. And just a recall that the conduction voltage required for a silicon diode is 0.7 volt, for germanium diode it is 0.3 volt, and for gallium arsenide it is 1.2 volt. Let's go to question number 10 straight away. We have to determine output voltage V out, and the current through the diode as shown here for the network. Now there are two questions, part A, part B. We'll solve each of them. Part A, first of all, this is the question. I always prefer to draw a battery with for the voltage given. So our circuit will be like this. We have connected a 12-volt battery here at this point. And now we can easily visualize that this 12-volt positive is touching the positive of the silicon diode and the positive of the gallium arsenide diode. So logically, both of the diodes should conduct. But there is a problem here. And that problem is that the moment we know the voltage across silicon diode is 0.7 volt. So the moment 0.7 volt is achieved here, this diode will start conducting, and the 0.7 volt will hold across this whole circuit, this parallel line. Therefore, it will not let this voltage rise more than 0.7. Now, this requires 1.2. So that means this diode will not conduct and it will become open circuit. So the upper one will conduct, represented by 0.7 volt. This will be open circuit. Now this is what is the explanation. The applied voltage across the gallium arsenide diode is 0.7 volt because it is 0.7 here. Hence this diode will be off. Okay, now with this circuit we can calculate the current and voltage. You can calculate voltage first, then current, or current first, then voltage. Both way it's okay. Let's see. First of all, we'll write the KVL equation. So from here, minus 12, 0.7, I into 4.7. So from here, we can current will be 0.24 milliampere. And now voltage, or okay, this current is the same as the diode current. So ID will be 2.4 milliampere. And now voltage, we can write directly from here I into R. So I into 4.7K, it will be 11.3. You can also get the voltage by the KVL method. So let me just show you. Minus 12 plus 0.7 plus V naught plus V naught. So from here also, we get the same answer, 11.3 volt. Okay, now part B is this question. Here we have the germanium diode and silicon. This requires 0.2, this requires 0.7. First of all, let's connect the batteries. So 20 volt at the top and plus 4 at the bottom connected. Now you can see we generally only consider the bigger battery to determine the current direction or the conductivity of the diode. Unless these two batteries are very close, like if it is 20 and the other one is, let's say, 19.5, then we have to consider the effect of both the batteries. Okay, now this battery is making the positive or touching the positive of the silicon diode, so this will be forward bias. But the positive of the battery is touching the negative of the germanium diode, so therefore this will not conduct. This will become open circuit, so open circuit. And now this circuit we can easily solve for V naught and I. So minus 20 from here, plus 0.7 and plus V naught. So we are first calculating V naught. V naught is 19.3. Now let's calculate current. As I mentioned, either way you can do, you can calculate current first and then voltage, or voltage first then current, doesn't matter. So for current from here, now V naught we have already calculated, so we can just use this loop. So V naught is I into 2.2 plus 4, and from here I will be 6.954. Or we can use the KVL equation, minus 20, 0.7 plus I into 2.2 plus 4 equal to 0, and from here also we get the same answer. So question number 10 done, and okay, the current is same as ID current, so it will be same value. Question number 11, we have to calculate V and I. Similar question. Part A, silicon and gallium arsenide. Now the voltage here is 1 volt, keep in mind. First of all, connecting the battery. Now this battery is making both of these diodes forward bias, but we know the gallium arsenide requires 1.2 volt, whereas our battery is only 1 volt. Therefore, this will not conduct, this will remain off. So off, and now the circuit, calculate voltage and current by KVL. Current first, minus 1, 0.7 I into 1K. So current is 0.3 milliampere. Voltage is I into 1K. So 3 volt, or by the KVL, minus 1, 0.7 is V naught. So V naught is 0.3 volt. And this is the answer given at the end of the book. Okay, part B. Again, we connect all the batteries. So 16 volt battery here, negative 4 volt through this battery. The bigger diode is making all 3 diodes forward bias. You can see positive touching here, through this touching here, through this touching here. So all 3 silicon diodes, so they'll be forward bias. Our circuit will become like this now. And now by KVL, minus 16, 0.7. Then either we can take this loop or we can take this path to reach V naught. So 0.7, we have to just consider one of it. 0.7 plus V naught is equal to 0. And from here we get V naught 14.6 volt. And now for current, again, same technique, we can follow either this path or this path. So minus 16, 0.7, 0.7, I into 4.7 and minus 4. So solving I is 3.957. Or we could have done from here as well. Let's see that. V naught is I into 4K minus 4. So I is 3.957 milliampere. So I hope you have been able to follow this question and you can easily solve this type of questions. Thank you.